Hello everyone, this is Group 4 and in this video, we will be discussing about functions and relations. Now what is a function and a relation? A function is a relation where each element in the domain is related to only one value in the range by some rule, while a relation is a rule that relates values called the domain from a set of values to second set of values called the range. There are a lot of variations of expressing functions and relations. First is by doing the set of ordered pairs. A set of ordered pairs is composed of two coordinates. The x-coordinate or the abscissa and the y-coordinate or the ordinate. In a set of ordered pairs, the domain is the all of x-coordinates while the range is the set of all y-coordinates. Here are some examples in identifying whether the given set of ordered pairs is a function or merely a relation. For first example, A is a set of 1 and 2, 2 and 4, 3 and 6, 4 and 8, and 5 and 10. The domains of this set of ordered pairs are 1, 2, 3, 4, and 5, while the ranges are 2, 4, 6, 8, and 10. Since there are no repeating numbers in the domain, this set of ordered pairs is a function. For our second example, B is the set of 2 and negative 3, 3 and negative 2, 4 and negative 1, 5 and 0, and 7 and 2. This set of ordered pairs is a function because there are no repeating numbers in the domain. For our third example, C is the set of 1 and 1, 1 and negative 1, 2 and 2, 2 and negative 2, 3 and negative 3, 4 and 4, and 4 and negative 4. Notice that there are repeating numbers in the domain. Therefore, this set of ordered pairs is a relation. For the fourth example, D is the set of 2 and 1, 4 and 2, 6 and 3, and 8 and 4. Since there are no repetition of numbers in the domain, this set of ordered pairs is a function. For the last example, E is the set of 3 and negative 1, 3 and negative 2, 1 and negative 3, and 0 and negative 4. Since there is a repetition of numbers in the domain, this set of ordered pairs is a relation. Another way of expressing a function and relation is by using the table of values. The table of values is the set of ordered pairs that may be written as a table of values, which is still made up of x and y coordinates. On the first row, the x coordinates are recorded, followed by the y coordinate. A table of values is a function if there are no common coordinates in the row of x coordinates. To write a set of ordered pairs in the table of values, simply write all the x coordinates on the above row and write all the y coordinates on the row below. The number of columns depends on the number of ordered pairs given, plus 1 for the column of x and y. Here are some examples of expressing functions and relations by using table of values. For the first example, A is the set of 1 and 2, 2 and 4, 3 and 6, 4 and 8, and 5 and 10. Place all the x coordinates on the first row of the table, while the y coordinates will be placed on the second row. As you can see, there's no repetition of numbers in the x coordinates. Therefore, this is a function. For the second example, we have B is the set of 3 and 30, 6 and 60, and 9 and 90. Again, simply place all the x coordinates on the first row and the y coordinates on the second row. As you can see, there are no repeating of numbers in the x coordinates, therefore this is a function. For the third example, we have C is the set of 1 and 1, 1 and negative 1, 2 and 2, 2 and negative 2, 3 and 3, 3 and negative 3, 4 and 4, and 4 and negative 4. Again, x coordinates on the first row and y coordinates on the second row. Since there are repeating numbers in the domain, this is a relation. For the last example, we have negative 1 and 2, 2 and 4, 3 and 5, 1 and 3, -1 and -2, and 6 and 8. Again, x coordinates will be placed on the first row and y coordinates will be placed on the second row. Since there are two -1s, therefore this is a relation. Another way of expressing functions and relations is through mapping. In mapping, functions can be written a mapping in which the values on the left side, which represents the x coordinates, will be matched with the values on the right, which represents the y coordinates. But before we move on to the examples of mapping, here are the types of relations. These are one-to-one, many-to-one, one-to-many, and many-to-many. Reminder that one-to-one and many-to-one relations can be considered as functions. Always remember that all functions are relations, but not all relations are functions. Now here are the examples of mapping. For the first example, we have A is the set of 1 and 2, 2 and 4, 3 and 6, 4 and 8, and 5 and 10. As you can see, the x coordinates on the left side are being matched with the y coordinates on the right side. This type of relation is using the one-to-one relation. Since one-to-one relations can be considered as function, this example is a function. The second example is B is the set of 1 and 5, 2 and 10, 3 and 15, and 3 and 20. Again, values on the left will be matched with the values on the right. Since this is using a one-to-many relation, therefore this example is also a relation. Another example of expressing a function and relation is by graphing. This uses the vertical line method to determine if a graph is a function or merely a relation. To apply the vertical line test, we need to draw a vertical line passing through the graph in the rectangular coordinate plane and determine the number of points of intersection between the graph and the vertical line. To know if it's a function or not, if there is only one point of intersection between the graph and the vertical line, then the graph is a graph of a function. But if there is more than one point of intersection between the graph and the vertical line, then the graph is just a relation. Another way of expressing a function and relation is through equation. An equation cannot be considered as functions if there is no y in the equation, the exponent of y is an even number, y is in the absolute value symbol, and the relationship is not in the equality form. Here are some examples of equations. First example is y is equal to x squared plus 2. This is a function because it is in equality form and has x and y. The second example is x is equal to x squared minus 3. This is not a function because there is no y in the equation. The third example is x is greater than y. This is not a function because it is not in equality form. The fourth example is y is equal to x plus 3. This is a function because it is in equality form and has x and y. And the last example is y squared is equal to x plus 2. This is not a function because the exponent of y is even. Now we move on to function notation. A function notation is a simpler method of describing a function without a lengthy written explanation. Functions are being written in different ways. Here are some examples. The first example can be written as under function f, x maps to x plus 3. The second example can be written as the image of x is x plus 3. The third example can be written as the function f is the set of all ordered pairs x and y, such that x is equal to x plus 3. The fourth example can be written as f of x equals x plus 3. And the last example can be written as y is equal to x plus 3. To write a statement into functional notation, determine first the dependent variable and independent variable. Then write the dependent variable on the left side and the independent variable on the right side. Here are some examples. The first example is the salary S is dependent on educational attainment E. The independent variable of this statement is S, while the dependent variable is E. Therefore, the answer is S is equal to f of E. The second example is the circumference of a circle C is dependent on its radius r. The independent variable of this statement is C, while the dependent variable is r. Therefore, the answer is C is equal to f of r. The third example is the price of gasoline G is dependent on the dollar exchange rate D. The independent variable is G, while the dependent variable is D. Therefore, the answer will be G is equal to f of D. The fourth example is the height of a person H depends on his or her age A. The independent variable is H, while the dependent variable is A. Therefore, the answer will be H is equal to f of A. The fifth and last example is the health of a person H is dependent on the food F they take. The independent variable is H, while the dependent variable is F. Therefore, the answer will be H is equal to f of f. Now, let us move on to our last example on how to express function and relation. Our last variation is through piecewise defined function. A piecewise defined function is a function that is defined by two or more equations over a specified domain. Here is an example. A user is charged 400 peso monthly for a particular mobile plan, which includes 100 free text messages. Messages in excess of 100 are charged 1 peso each. Represent the monthly cost for text messages using the function T of m, where m is the number of messages sent in a month. The cost of text messaging can be expressed by the piecewise function. If the user sent 100 or less messages, then the user will only pay 400 pesos. But if the user exceeded 100 messages in a month, then each message will be charged 1 peso. Let's say, for example, 120 messages are sent within that month. Since the 100 messages are part of the 400 peso mobile plan, there is an excess of 20 messages. And each message will be charged by 1 peso. So the excess messages is equivalent to 20 pesos. If you add all of those together, then the user will pay 420 pesos for that particular month. So these are the different ways of expressing functions and relations. We hope you learned something in our video discussion. This has been Group 4 and would like to say goodbye.